another coding session. I'm going to tear through some more of this. Tear through. Last time we took care of one bullet point last time. But let's see if we can beat that this time. I had a bit of a think about what I wanted to try. A lot of these I feel like are not very big things. And I didn't want to have like just a kind of a bits and pieces video. I think I'd rather try to tackle something biggish and then put bits and pieces on the end. So this is the one that I have thought would be nice to do. There isn't a place where it stands out as an issue, which is in Boomstick, I think. Yeah, here we go. This is where we're doing some equals and we said, hey, it'd be nice if this was generalized, because equality at the moment can only be done on, I think it's like number types and bool. Yeah, pretty sure you can do it with bool. And that's it. But I think you should be able to do equals equals with anything, basically. Also not equals. Equals or not equals should be possible with anything. So I have done a bit of investigation into this, like how to do an assembly. Probably have to find it again. Where's our conversation? Checking byte equality. So this conversation here, I always find it so hard to in Grok to see this scroll bar. But this should help us out when we get to it. So that basically that'll allow us to loop through bytes and check whether they are the same, which is what a generalized equality means, I feel like. And while we're at it, we're also going to handle equality with nil. And nil in my language is a bit different, I think, because nil is also used in Odin, the language I'm using to write the compiler. But I think in my language it's a little bit different. For me, nil means all zeros, whatever the data type is. So if it's a struct, it means that all of the members are zero. It means that basically in memory, the struct in memory is all zeros. That's what it means, which is also what it would get initialized to. If we created a new struct and we didn't assign anything to it, it would get initialized to all zeros. And this is checking that it's all zeros. We can also assign, I'm pretty sure this already works. We can assign nil to something and it will zero everything out. Even an array, we could check an array with nil and that would check that all of the elements are nil. The elements could be structs and they all need to be zeroed out. We could assign nil to an array and that would zero out all of the elements. So nil is like zero, but not just the number zero, it's like the concept zero for everything. Anyway, I think that's enough explanation of nil. Let's get this equals equals going. So I guess we want to go to type checking an assignment. Sounds like the place to start. So in here, depending on what type it is, we allow or do not allow certain. No, it's not assignment. This is not an assignment, is it? This is a binary operator. So that's a right-hand side expression. So, and right-hand side expression 1, this is where we're actually using binary operators. So we say if it's not a binary operator, we do this. Otherwise, we come down here and here we go. So this is where we say what types are allowed to use binary operators. So I think, so these are all the ways they can fail. So basically what I want to say is that if we're talking about equal or not equal, then I don't care. Like mostly this is checking the types involved in the operation. Coerced type node is bool. Well, that'll always be the case. If we're doing equal or not equal, coerced type. That's an interesting point. Because the result of equal and not equal should always be bool. So this is kind of where we set what the types are. If it's a comparison operator, then the result is a Boolean. Okay, great. There's comparison operators, so the result is a Boolean. So, so actually we're saying, we'll go back. If it's not one of these, then we want to do a bunch of checks. Because if it is one of these, then we skip all these checks and we just say, all good, we can do it. So there's no point in having these checks here, because we already check up here. I think that's the only place they appear. Looks like it. Okay, cool. So that should free us up and say that we can compare anything to anything. So now during the actual comparison, and I just realized that GLSL, we also need to handle this. Yeah, that'll be for something for later. So there would be an expression with our binary operators. So if our operands are, so if our operands are any of these things, then we want to do what we were doing before. They all have comparison code in them, which should be nice, simple comparison code. Like this is just a one line to do the compare and then one line to set the resulting Boolean. So it's nice and simple. So we want that to happen first. And if none of those apply, then we want to go to, do we really need to know if there's allocations in these? Like if I go to here, this contains allocations, but it looks like it's not actually used. I'm going to cut them out and see what happens, because somehow I feel like they are not needed. I think we do need to pass them in because primary needs to know about it, but these don't need to pass them in. Yeah. So here it's more like generate expression any. And let's just take this signed integer 1, copy it down here, and call that any. And it's all about comparison. So we can't do these kind of comparisons, though it's just equal or not equal, and there's no such thing as adding, subtracting, all that kind of business. So we cut that out. So we don't need to have a check if it's a comparison operator, because it is. And if it isn't, then we fail. Okay. All right. So what do we need to do differently? Well, to compare arbitrary sets of bytes, it's similar to when we do a copy. So here's a copy, and here's our copy of arbitrary memory to memory. So maybe replace that. This is the actual operation. So yeah, it's similar to this because this is where, like, I guess we don't need a final comment. This is like a compare. it's a similar similar operation. This was move, i.e. it's a copy. But here we want to do compare. Yeah, compare. So it's going to repeat doing a comparison through here. It's not so much source and destination, it's more like left-hand side, right-hand side, and it doesn't even matter what's on the left and what's on the right. So that's, I guess, the left-hand side location and the right-hand side location. And we don't need to put it in a register, I don't think, right? The size, I guess, is the operand. So 2 byte size, the operand. And another difference is here, it's like rep for repeat. But here I think, yeah, rep E repeats this operation while the 0 flag is set, i.e. while they're equal, and while the counter is non-zero. So while, you know, while we have more things to compare and there's equal, then it keeps going. But as soon as it finds something different, it stops, which is good because when we're checking for equality, as soon as we find one byte that's different, there's no need in continuing. We know that we found something different. And then how do we report that? Well, we report it in exactly the same way because it sets flags just like this other compare up here sets flags. This compare sets the same flags. So we can then just do our regular set E, set not E. Cool. That's, I mean, actually pretty easy. So let's try that, I guess. I'm always so like averse to doing tests because it just takes so long to run the tests. But let's add some tests. We really should. So we have all these if tests for add. I guess they're like could be like value tests. Declare. What else we got in here? Procedures. So type aliases. Here we go. Equality, not equality. So this is just a bool in bool tests. Equal, not equal. So this should move up, I feel like, to value tests. And then do a numerical test, the same thing. Oh, that's less than. Yeah, so these numerical tests, let me just double check. I think they're exactly the same. Yeah, it looks exactly the same. So we had it for numerical and bool, but now it works for everything. Do we run our value tests against strings? I don't think so. We do it for bools, we do it for numerical types. That's it, bools and numerical types. So actually, this is not as much as we would like it to be for. We have, you know, we could have structs, but I'm not sure I want to, or not. Type alias, procedures. I'm just trying to think whether we could add to our values tests things like pointers, structs, all that kind of stuff. Like if I say pointer code value test pointer, and the type is like just say pointer to I8. But then assigning values, that's the tricky bit. How do you assign a value to, like this one could be nil, and this, well, I guess I could do like untyped 1 and 2. What do we do for the numbers? 1 and 2. Yeah. Okay, let's do untyped 1 and 2. See what happens. I have a feeling that's not going to work. Cannot index type. Because we need to, I think I need to put it in brackets to make sure it figures them out correctly. Getting a bunch of segmentation faults. Type 0 was not found. Cannot index type I8. Type alias array. Type alias array. Type 0 was not found. Should be an alias to that. Cannot index type I8, which is in line 4. Oh, weird that that came up before that, but so cannot index type I8. Well, I'm a little confused. I mean, this is a type alias. Okay, I think I might have bitten off more than I can chew here, trying to make them value tests. Let's roll this back, and for now, we'll do general tests, but really I think we should expand our value tests to handle a lot more stuff. So if I go up here and I say I want another general test, and it's like equals, yeah, we'll say equal, general tests equal, and we'll say like I32. Let's say equal. Oh, we don't have nil yet, so var 1 can be an F32. That should work. Well, all with numbers and booleans we already have working, so what do we really want to test here? It's like I was saying, it's like a pointer, an array. Should be able to check that they're equal. Pointer, array, maybe a slice. So we say like var1 : slice should be comparable. And then maybe a struct can compare a struct. That should work. Closing square bracket found, colon. Oh, that should be equals. Cannot redefine, so that should be bar 3. Okay, so all of those comparisons worked, and they should have all been using well, I guess really we should probably do something like that, right? We should check the negative side too, so that's like 2, 3, no, 2 equals 2, but 2 does not equal 3. This is 4, 5. So I guess this will be bar 2, bar 3. Like so, and this will be 6, 7, 6 equals 6. A equals 1, B equals 1. But 6 and 7 are not equal. Let's try that. Any number and pointer not compatible. Ah, right. This is where probably just say untyped. So we're just putting like dummy addresses in these pointers. Ooh, assertion failed. Okay. Just one assertion though. I really should have put descriptions in them. Probably these, because these are equal. And let's make that 2. So then they should be different. Okay. So I feel like that's equality working, equality and not equals. So now we need to compare with nil. So instead of comparing two memories, we need to compare memory with 0. I found a way to do that as well. And how to check if bytes are 0. And it's scazib. Scazib instead of kimpsib. And we put the memory in RDI, and in AL we put 0 to say that we're checking with 0. So we kind of need to know I guess, so what if it's like node.type equals null? What do we have on the left-hand side and the right-hand side? I guess if we get here and these are immediates, the only reason they would be immediates, if we got here, that means that it's not, you know, if we got here, it means that we're not talking about numbers, we're not talking about booleans. So everything else should be memory, not immediate. So if we find immediate, it's probably because you should see here that in primary, if we come across a null, we set at immediate 0. So, I mean, to be really clear, we can say immediate and value equals 0, but I'm lazy, so let's just say if both of the locations are 0, would we even come in here in that case? I don't know that we would. I'm not going to handle that case. We'll see what happens. So if left-hand side is immediate, then the left-hand side AL. And we're just setting these registers now. Oh, not that one. So moving into AL, we move 0. And the right-hand side goes here. Otherwise, if the right-hand side is immediate, so the right-hand side is null, we do the opposite. So now we have the left-hand side, right-hand side, left-hand side. And if neither of them, then we do the regular loading of both the memories. The comparison size is always the same, and the difference, isn't there a different thing here? Oh yeah, it's compsib or scasib. So let's say nil compare is that or that. And what did I say the other one was? Scasib. I guess it's like scalar, like a scalar compare. I don't know. Something like that. Cool, I guess these are not formatted. I guess that should work. So if we go back into our tests and so maybe I'll change these to 0 and 1. So that's 0, 0, 1, 1. Then we should be able to see that that equals null, and that does not equal null. And the same with all these. var 4 is null, var 5 is not null, var 6 is null, but var 7 is not null. Something like that. I think that should work. An insertion failed. Only one though, it looks like. Let's see if we can track it down. Well, that should be var 1, right? That should be var 3. I feel like I'm still going to get problems. var 3 does not equal null. var 5 does not equal null. var 7 does not equal null. Okay. I, J, K, L, M, N, O, B. Which one failed? I failed. So var 4 does not think that it's null. Ah, that's correct. because for a slice to be nil, the pointer to the data needs to be nil. And in this case, it's not. So actually, it would need to be like this. Then it should be nil. So it would just be declaring it without assigning anything. That should be nil. Okay, yeah, that worked. I probably should have some convention of putting some values in there so I know which assertion goes wrong, but let's figure that out later. Let's just double check that this works. The tests are definitely faster than they were before. Cool. Okay, so this is where we had the issue, where we had to do this silly stuff. So we should be able to do that now. We still have to do untyped, unfortunately, in this case, because GLSL kernels, they say they're string pointers. I mean, really, they're so we're either going to have to do untyped here or here. We're going to have to do it somewhere, like this. We would have to say, like, actually, it's a string in here. So this is quite a special case, actually. But at least that removes this here, and I can also remove it here. Well, let's get the proper one. Like so. Let's just check. I guess if there's anywhere else that we might be able to fix it, it probably has untyped. It's probably in bang code. We need to look. So that's not a comparison. These are the comparisons we just looked at. Any other comparisons? Don't think so. Mostly it's for... Yeah, I think that was it. But that's nice. Well, let's see that it actually works. I was worried for a second there, but we have the test turned on. That's why it's taken so long. That was a bit slow. Are we using... we're doing it on the GPU. So performance is all over the place, but if we were using the GPU, that means that it was going through here and it found it still. So that's pretty cool. That's pretty cool. I'm happy with that. So that is this feature here. We're only like half an hour through. So I'm kind of wondering if we should tackle some more features, some small features, or some bugs. Let's go for some bugs. Let's go for some small bugs. Well, we have half an hour, right? Maybe we can start from the top. So cyclic imports are an issue. And why is it a problem? I know in a lot of languages cyclic imports are issues. That doesn't necessarily mean it's going to be an issue in my language. But I think the one reason that it would be an issue is because modules can have code that runs just right at the start of the program, right? And if one module is dependent on another module, for example, our main module is dependent on Boomstick. So the code in Boomstick really needs to run first before the code here. We don't want to run Boomstick and init before we've started the thread pool. Well, Boomstick and init would be fine, but you know what I mean, This stuff should run first. And if we have a cyclic dependency, it may, like if this happened to be dependent on this, we don't want this code to get put into the executable before this. So the ordering of the code could get messed up. So what I'm thinking as part of type checking, this is like type checking a module. We don't really have a type check program, do we? Type check program, I guess, would like maybe encompass all of this stuff. Tokenization is just tokenization. Parsing is on the module level. But maybe we need a type check program. And that would include that, because I don't really want to include it in main. You know, I kind of also don't like the idea that we have to set this stuff up on main. So let's go new file program.odin. And we mostly just want to grab this code here, I think. It's like type check program. Let's cut a lot of this. Let's cut everything out. So we can figure out what we actually need. Probably we want to pass the program in. Well, this load module kind of is something that gets called in a couple of places. Import program. Name code. I'm really indecisive about what belongs in here and what does not. But when we type check a module, we do this kind of stuff, right? Like with the import, you know, we read the file even, and then we load the module. Here we're not reading the file. We just have code. We have to use the program because of the prefix business. And I'm just going to return a bool. So load module or return. We don't need to prefix this. This is also or return. I think that's basically it, right? And return true. Okay. So then if we move that into main, it should be like type check program and give it that program. And we also need name and code. Yeah, so it becomes just that, type check program. And the reason we moved this in, well, let's just check that it works. Promising so far. Okay, cool, that worked. And the reason we did that was because now I want to do like it's like type check cyclic imports. I don't know if that's the right name, but and then I also, I guess, pass this in. Is that going to get changed? I mean, obviously it gets stuff added to it. I'm just wondering if the module name or the procedure name or anything like that, if it changes, but I think we do this copy before changing anything like that. So let's see. Maybe we can just pass this context in and it just works. Put this here and just say, hey, I want a context. And I don't care about anything else. And what do I actually want to do? So I guess what I also want to pass is like, I guess a dynamic array of strings, which will hold the path it's like the import path, we'll call it. And we kind of want to go from module to module, right? So we get in the current module and we want to verify that none of its imports, it's like for import name, let's go module. Might just be that we just need to pass the module in here. That might be nicer actually. So for all of these, imported module name is the value in the map. And then we do a linear search. Slice up linear search and we fix up this terrible import. And we're searching for this in import path. Oh, well, I guess we just need to actually change that to a slice. And found module name. And then I think there's like another return that I don't care about. No, it's the first one that I don't care about. I don't care about the index, I just want to know whether it was found or not. And if it's found, then we throw an error and return false. I think that's the idea. So when we type check module, we probably have an example somewhere, maybe not. Type check assignments, somewhere we need to, here we go. So we have something like this. We need the source position. Well, I guess this is not really a position message, is it? It's just, yeah, so instead of source, I think we actually just need format. We need to say like cyclic import detected. And then how do we actually say what the import was? We can print this import path and we can print where we are right now. I'm going to say this should just be a module. So I guess we need to go program.module. And then we need the name, I think. No, but that should be in the path. That should be in the path. Yeah, so maybe we just need to put the import path. Let's try that. And we return false. And, or if it's not found, then we want to continue, right? We want to append to import path the imported module name. We're not going to be able to get the module though, that's the thing. I think we need the program and the module name. Let's try that. Well, we put in the imported module name on, and yeah, and then we're going into, no, then we're going into that module. So maybe we put that module name on the path, the module we're just working on. Put that one onto the path, which doesn't need to have that. And then we pass in the import path, the program, and the module name, which is the imported module name. We all return. We also need to clean that up. Do we need to clean that up? I don't think we do actually, because if we end up all returning, we're just going to if any of these returns false, then we're just going to keep returning false up and up and up. And I think we're never going to use import path again. But like after we do this, we need to remove module name. Or maybe it needs to be like this. You know, we add this module on and then we check all of its imports. And then we take it off again. So how do we take it off actually? Advanced types, dynamic arrays, appending, removing. Pop. I think pop will take, pop's the last element of the array. That's what we want. Just pop. Okay, and module is program.modules module name. But I need to spell it right. Well, I guess we can just do that, right? It's the only place it's used. No, it's not. It's used here also. Okay. I think that kind of does it. Let's see what happens. So we need to pass in the right stuff here now. So we want the program, the module name, which should be name, and we need to create the import path to start with. And because I figured out we need to do this, so then we pass a pointer to that. So if we think this through, the first time we come in here, this will be empty. We come in here, we add the module name to the import path. Then we check, is the imported name on the import path? So that sounds right. Imported name should not be the same as that. So module name is on the import path, so we don't need to, it's like, yeah, it's more like imported module name, imported at path, blah, blah. Okay. And then we recurse with that imported module, and then we pop. Yeah, I think it looks good. So it seems happy. So then what if we look at like, or threading. Let's try threading. So Boomstick imports threading. What if threading also imported Boomstick? I guess all the tests don't use these files, so it would be a problem. Oh, here we go. Cyclic import detected. Core threading imported at path from here to threading to Boomstick, and then it did that again. Nice. We could format this nicely, especially this ampersand. I guess because it's a pointer, like probably if we did that, gotta do the good old test disable. Yeah, that gets rid of the ampersand. I think that's good enough for now. This could be improved, but yeah, I think that looks pretty good. So we're preventing cyclic imports. So where do we add that cyclic import? Here. So now it should run fine. Cool. So we're preventing cyclic imports. Did I? Wow. That was confident of me to just take it off straight away. We're still under an hour, but we just have like a tiny amount of time left. So let's do some little things. What are some little, maybe we'll go to cleanup, hey? Do some cleanup stuff. Like this is a nice little cleanup. I wanted to have an os.time and a time val t. So what I'm referring to is that currently in our standard library in the Linux file, we have this get time of day, which returns a pointer to an array of I64s. But I want to make a type for that I believe it's seconds and then like nanoseconds. One thousand millionth of a second. I think that's right. I think they're nanoseconds. So then it's like a pointer to a time val. Is actually what we're putting in. And then I also want to make a new file, os.bang. And in there, I want to have time as a proc, takes no arguments. And it does basically what we do here. Because it's a little bit annoying, this thing. I don't really want to have to manually do that. I guess this should return an I64, but because the gist of it is when you want to get the time, you pretty much always want to do this, which is then combining. So this is like it's 1/1 millionth of a second. I think that's what it said for nanosecond, right? 1/1 millionth. 1,000 millionth. One millionth. Okay, so maybe it's a microsecond. It's called a microsecond. I might have that wrong. I'm not really too fussed about it though. So this is going to need to import Linux. Linux equals import OS Linux. So this is going to be linux.timeval t timeval, and then we're going to say timeval.seconds and timeval.microseconds, and we're going to return that. That's a more useful time, like it's giving us a timestamp, basically, an epoch timestamp as one I64 instead of having it split up. And that's like, I've never come across a situation where this was needed, looking at these individually. So let's just get time. I guess sometimes maybe you only want to know seconds, but you can figure that out from this anyway. So once we've got that, we should then be able to say, is that the only thing that we use Linux for? Good time of day, good time of day. Yeah, okay. So we can just say core OS, and then we can say FPS time equals os.time. Boom, much easier, much cleaner, right? And then down here, the next place we use it here, time equals os.time. We need to record it because we use it in a couple of places. And that works. FPS counter works, which is what we're using it for. Cool. So that was a nice little thing that we got done. What are some other little things? GL takes this instead of C string. I think we can do that. So vendor GL. See, there's one place here where we take a C string, but I wanted to change it to this because a C string is a string that's null terminated by convention. But if we're also passing in the length, then there's no need for this to be null terminated because we're explicitly saying how long it is. The only reason for the null termination is to determine the length. So, so I thought maybe we do that so it doesn't force us to use a C string. So that's going to break a couple of places. namely here. So let's pass a string into here. And we should be able to just go source.raw and source.length. Length is an I64 though, so we'll cast it to an I32. And up here where we define them, string is the default, so we don't have to explicitly say it's a string. We don't have to explicitly put the length. Did I take that parameter off? Yes, okay. So that takes care of that, but then also in the boomstick, we have, we use it here. So I guess here, we don't need this, right? We can just say pointer to raw. Yeah, it all works. Okay, so that was just a little tidy up thing that I wanted to do. Get rid of that. Where are we? We're at an hour, but I kind of feel like we can do some more stuff. This is a little bit of logic, so maybe it's not so good to do here. Balance checking. Trying to see what else is really easy to do. Okay, so a really easy one I think I saw was this, switch to I32 where possible in Bancode. So because we used to use I64 a lot, overused it in my opinion, and the only reason was because Bangalang could only index using I64s. But now that it can use any integer, we don't need to be using I64 so much. So I think like this one could be an I32. This one as well. This is just for indexing. And this is getting converted to an F32. Frame count, I'm sure that can be an I32. I guess the downside of that is that I2A currently only works on I64s. Yeah, so we'll leave that as an I64 because of I2A, but hopefully we can get I2A to work on any kind of integer in the future. Index. Yeah, I feel like that's new code, but I feel like that does not need to be an I64. Kernel indexed. Why is that an I64? I feel like that does not need to be. And buffer index. Also, this one I think does right now. Well, the reason it does though is because we have because of our thread pool. So well, let's just keep going through here, but I think the thread pool and boomstick can be reviewed a bit. So this stuff needs to be I64s. Yeah, all this Linux stuff I think should just stay. Strings, yeah, like I say, I2A needs an I64, but this is, we need to get into generics to fix that. Length, I guess, doesn't need to be an I64, but let's leave this procedure for now. Yeah, like I said, let's leave that procedure. So threading and OpenGL, if I used an I64 here, it was because it needed. So threading and boomstick is what I want to evaluate here. So I64 The argument I do want to be an I64, yeah, so all that stuff will leave. Here, the thread pool, this stuff I don't think needs to be an I64. Thread argument, yes, because it's actually a pointer. Again, this is something that we solve with generics. Oh yeah, I want to have max. I want to be able to do that to get the max value of a type. This, because worker count is now an I32, we can change that one. And now that we changed those things to I32, I believe this can be an I32 because worker count is I32. So then it's like this data length needs to be cast to I32, and then these do not need to be cast. Let's see. We missed one. Boomstick 17. That's why I used I64 there, because the length is I64. I was wondering, I was like, this is new code. Why am I bothering to make that I64? It's because of that. I could make it I32, but like, what does it matter? Boomstick 33. And that's also, I was wondering, like, why do I use I64s here? And it's because we're comparing with lengths. Okay. All right. That's all working. We're at an hour 6. Not a super long session. But I think we cut out, we still have a lot, but we managed to cut out a few things there. So yeah, it is going to take a while. I think it's going to take a while to get all this stuff down. There's a lot. There are a few more things, like, especially, like, I think that's a small one. There are quite a few more small things, actually. Just I feel like at this point, maybe we shouldn't try any more small things. We've got a few small things there and a couple of big things too. So I'm pretty happy with the session. And stoked just to see the language just like slowly refine at the moment. That's kind of the idea. There's going to be a bunch of refinement happening. I think we'll do the refinement first and then get stuck into some of these bigger features. I mean, break continue we should really have. I feel like that's just a regular thing that we should have. But and I don't think they would be too hard. I always thought exit, actually, that's another easy one. Actually, let's do that now. Let's do that now. I just don't want, what do I use? We have linux.exit. Yeah, so these core files, even in the core library, I feel like we should not use, well, I guess we do need to use Linux quite a lot. Okay, let's not worry about exit right now. It's only used in the core library. If we did want to try and use exit in our example code, I think the big idea is that I don't want to have to explicitly import Linux in a project. You know, in the standard library, fine. But in a project, I don't want to have specific Linux and Windows and Mac code if it's really easy for me to do a wrapper. You know, like, hopefully it should be easy for me to replicate this for other platforms. And exit, I mean, should be very easy. Okay, cool. Happy with that progress. So that's it for now. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.